Well, smart learners, today you will learn about object-oriented programming in C++ with the help of examples. So in this video, we are going to discuss characteristics of OOP language, C++ and C, problems with structured programming, unified modeling language which is known as UML, and why do we need OOP? So the question here is that why do we need OOP? What does it do that traditional languages such as C, Pascal, and BASIC don't? What are the principles behind OOP? So the two key concepts in OOP are objects and classes. What do these terms mean? What is the relationship between C++ and the older C language? And what are procedural languages? C, Pascal, Fortran, and similar languages are called procedural languages. That is, each statement in the language tells the computer to do something. Gets up input, add these numbers, divide by 6, display the output. A program in a procedural language is a list of instructions. When programs become larger, a single list of instructions becomes unwieldy. Few programmers can comprehend a program of more than a few hundred statements unless it is broken down into smaller units. For this reason, the function was adopted as a way to make programs more comprehensible to their human creators. Now we'll discuss that what is a module. The idea of breaking a program into functions can be further extended by grouping a number of functions together into a larger entity called the module. Now we'll discuss that what are the problems with structured programming. As programs grow ever larger and more complex, even the structured programming approach begins to show signs of strain. You may have heard about or been involved in horror stories of program development. The project is too complex, the schedule slips, more programmers are added, complexity increases, cost skyrockets, and the schedule slips. So, analyzing the reasons for these failures reveals that there are weaknesses in the procedure paradigm itself. So what are the reasons for these problems with procedural languages? There are two related problems. First, the functions have unrestricted access to global data. Secondly, unrelated functions and data, the basis of procedural paradigm, provide a poor model of a real world. Let's examine these problems in the context of an inventory program. So one of the important global data item in such program is the collection of items in the inventory. Various functions access this data to input a new item, display an item, modify an item, and so on. Unrestricted access. In a procedural program, one written in C, for example, there are two kinds of data, local data and the global data. Local data is hidden inside a function and is used exclusively by the function. In the inventory program, a display function might use local data to remember which item it was displaying. Local data is closely related to its function and is safe for modification by other functions. However, when two or more functions must access the same data, and this is true of the most important data in the program, then the data must be made global. As you can see in this picture, there are two functions, function A and function B, and there is a global variable that is accessible by any function, whereas the local variable of function A is accessible only by function A, and the function local variable of the function B is only accessible by function B. Whereas if we look through a large program, there are many functions and many global data items. The problem with the procedural paradigm is that this leads to an even larger number of potential connections between functions and data. So this large number of connections causes problems in several ways. First, it makes a program structure difficult to conceptualize. Secondly, it makes a program difficult to modify. A change made in global data item may necessitate rewriting all the functions that access that item. For example, in our inventory program, someone may decide that the product codes for the inventory item should be changed from 5 digits to 12 digits. This may necessitate a change from a short to long data type. Now all the functions that operate on the data must be modified to deal with the long instead of a short. Now we will discuss real-world modeling. The second and more important problem with the procedural paradigm is that its arrangement of separate data and functions does a poor job of modeling things in the real world. In the physical world, we deal with objects such as people and cars. Such objects aren't like the data and they are not like functions. Complex real-world objects have both attributes and behavior. Example of attributes are eye color and job title, and for cars, it is horsepower and the number of doors. As it turns out, attributes in the real world are equivalent to data in the program. Whereas if you talk about behavior, then behavior is something a real world object does in response to some stimuli. If you ask your boss for a raise, she will generally say yes and no. If you apply the brakes in the car, it will generally stop. Saying something and stopping are example of a behavior. Behavior is like a function. You call a function to do something and it does it. Now, what is the approach of object-oriented? The fundamental ideal behind object-oriented language is to combine it into a single unit, both data and functions that operate on that data. Such a unit is called an object. An object's function called member function in C++ typically provide only way to access its data. If you want to read a data into an item in an object, you call a member function in the object. It will access that data and return the value to you. You can't access the data directly. The data is hidden, so it is safe for accidental alteration. Data and its function are said to be encapsulated into a single entity. So this is the object-oriented paradigm, which consists of a number of objects which communicates with each other by calling one another's member function, and this is how the organization of a C++ program is. You might want to think of objects as departments, such as sales, accounting, personnel, and so on in a company. Departments provide an important approach to corporate organization. In most companies, people don't work on personal problems one day, the payroll the next, and then go out in the field as salesperson the week after. Each department has its own personnel with clearly assigned duties. It also has its own data. The accounting department has payroll figures. The sales department has sales figures. The personnel department keeps record of each employee, and so on. So what are the characteristics of object-oriented languages? If we talk about physical objects, then automobiles in a traffic flow simulation, electrical components in a circuit design program, countries in an economic model aircraft in an air traffic control system. If we talk about human entities, then employees, students, customers, and salesperson are real-world objects in a program design. Moving forward to next thing, which are classes. In OOP, we say that objects are members of the classes. What does this mean? Let's look at an analogy. Almost all the computer languages have built-in data types. For instance, a data type int, meaning integer, is predefined in C++. You can declare as many variables of type int as you need in your program. For example, int data, int count, divisor, and int answer. In similar way, you can define many objects of the same class. Moving forward to next thing, which is C++ and C. C++ is derived from C language. Strictly speaking, it is the superset of C. Almost every correct statement in C is also correct statement in C++, although the reverse is not true. The most important elements added to C to create C++ concerns classes, objects, and object-oriented programming. However, C++ has many other new features as well, including an improved approach to input-output and a new way to write comments. Now we'll discuss that what is UML. UML is graphical language for modeling computer programs. Modeling means to create a simplified representation of something as a blueprint models a house. The UML provides a way to visualize the higher level organization of programs without getting mired down in the details of actual code. So why do we need the UML? One reason is that in large computer programs, it's often hard to understand simply by looking at the code, how the parts of the program relate to each other. As we've seen, object-oriented programming is a vast improvement over procedural programs. UML is not a software development process. Many such processes exist for specifying the stages of the development process. The UML is simply a way to look at the software being developed. So in conclusion, I must say that OOP is a way of organizing programs. The emphasis is on the way programs are designed, not on coding details. In particular, OOP programs are organized around objects, which contains both data and functions that act on that data. So this was all from my side. Thank you so much for watching the video.